Namaskar and a very good afternoon to all the viewers watching NCERT's live and interactive program. I am Shivani Jha and you have all connected with us through PM eVidya channel number 10. Besides this, you can also connect with us on our official YouTube handles that goes by the name NCERT Official and NCERT PM eVidya Class 10. आप सभी को बताना चाहेंगे आज का हमारा ये आधे घंटे का सेशन क्लास 10th के सभी स्टूडेंट्स के लिए है and the subject is science, and yes, the topic that we are going to cover today is the human eye and the colorful world part 2. इसका मतलब पार्ट 1 तो हमने अपने पहले के सेशंस में ऑलरेडी पढ़ा हुआ है, बट आज पार्ट 2 में हम क्या कुछ कवर करने वाले हैं एंड क्या क्या पढ़ने वाले हैं. सो टू delve deeper into this entire topic, we are also joined by our esteemed expert, Mr. Ish Kumar Gogia. Sir, namaskar and welcome to our session.
Namaskar. Thank you.
Let me tell our viewers, sir is formerly PGT Physics from केंद्र विद्यालय संगठन, and yes, सर के साथ हमें ज्वाइन किया है हमारी इंडियन साइन लैंग्वेज इंटरप्रेटर सोनल ने. तो आपका भी बहुत बहुत स्वागत है हमारे साथ इस सत्र में. And now, dear viewers and our learners, in case if you have any queries or doubt regarding our session or topic, then you can also contact us via phone or our email ID. Our phone number is flashing on your screen, which is 8800440559, and our email ID is dth.class10@ciet.nic.in. And as you all know, the session of ours is live and interactive. So you can also drop your comments, your queries or your feedbacks in the live chat box option. And now we are starting our session, and firstly, sir मैं आपसे यही जानना चाहूँगी, like as I earlier told our students, हमने first part इसका cover किया हुआ है अपने firstly session में. एंड उसमें आपने अलग अलग आई की अगर हम ये बात करें कि क्या क्या दिक्कतें होती हैं, क्या क्या प्रॉब्लम्स होती हैं, उसके बारे में भी पढ़ा था. बट आज के इस सेशन में क्या पढ़ेंगे एंड फर्स्ट सेशन में क्या क्या हमारा रिकैप था, मैं चाहूँगी उस पर आप ब्रीफली स्टूडेंट्स को बताएं.
लास्ट सेशन में हमने बात की थी कंस्ट्रक्शन ऑफ ह्यूमन आई की. वी विल जस्ट गिव अ क्विक रिव्यू ऑफ दैट. वी डिड मेंशन द डिफेक्ट्स व्हिच अकर इन द विजन. But we did not cover the correction. Today we will cover the correction of the defects of human eye.
Okay. And also the explanation, right sir?
Yes, we will explain. Okay. And then one thing more, remember these are the defects and not diseases. They can be corrected, cannot be cured. Okay. So we need external aid to correct the defects.
Okay, so fine.
Now a quick view of the human eye and only the refraction part, because construction we have already talked about.
Okay.
Today's lesson we will recap construction a bit, then correction of the defects, and then refraction of light through the prism, because that is what will take us to the colorful world, and which completes the name of the lesson. Okay, so this picture of the human eye is on your screen. The lens system consists of the pupil, which is the front part of the eye. Behind pupil we have the aqueous humor, then the crystalline lens, and behind the crystalline lens in the eyeball we have vitreous humor. All this forms the lens system and it produces the image in the eye. But the eye is normal or correct, free from all defects, provided the image is formed on the retina. The eye accommodates all objects which lie from 25 centimeter to infinity, provided it is normal, free from defects. So for all objects between 25 centimeter to infinity, the image is always produced on the retina. This adjustment is done by the lens. There is fine adjustment in the shape of the lens
to form the image.
With the help of the muscles, ciliary muscles, they increase the focal length. They change the shape of the lens to increase the focal length or decrease. And wonderfully, the image is always on the retina. For a normal eye. Okay. Now coming to the near point, normal near point, as I said, is 25 centimeter. So when the object is at 25 centimeter, that is at N in the diagram, the image is on the retina. This is normal eye.
Normal eye.
And normal near point is 25 centimeter.
Okay.
Okay. When we come to the far point, the eye can accommodate all objects which lie at infinity.
Infinity.
So, from infinity, the rays are in the form of a parallel beam, as you can see in the diagram.
Exactly.
And the image is again on the retina, and this is achieved by change in shape of lens, and it is so automatic, so quick. Like when you are looking at your screen, image is on the retina.
Exactly.
When you look at the sky, meanwhile the lens has changed its shape, so that the
It's
image is
changed too
again on the
fast, right.
retina. Yes. So we don't have to do anything about it. The nature does it. Now, refraction defects, we have already named the defects earlier. Myopia, which is also called short sight or near-sightedness. Here the eye will be unable to see far off objects clearly. The sight has become shorter, means you cannot see far off objects. Here sight has become shorter.
Okay.
The other defect is hypermetropia or long sight or farsightedness.
Farsightedness.
Here you cannot see the nearby objects clearly.
Okay.
So you far sight. You're far sighted.
this is a
You can see
opposite.
far off
Yes.
objects clearly, but not nearby objects. Presbyopia is because of the age, and we'll talk about these defects
Okay.
once
So
again
these are the three
in
defects.
detail, and then we'll also talk about the correction of these defects.
Okay. Okay. So shall we proceed, sir?
Yeah,
What's
sure.
his explanation?
Sure.
Okay.
The defects are corrected by suitable lenses. Myopia, as we said earlier, is nearsightedness. Myopic eye is unable to see distant objects clearly. We talked about it.
And these all defects can be corrected.
Corrected,
Yes.
yes. You got it
Okay.
right. The image of distant objects is formed in front of retina and not on the retina.
Okay.
You can see here, normal eye, this image would have gone to retina. Object is at infinity, but image is in front of retina. There are two possible problems. Either the focal length of the lens decreases or the eyeball becomes longer.
So
the
in this
eyeball is
defect,
longer.
sir, the image will formed on retina or not?
No, in
No.
defective eye, you
In
don't get
defective eye.
image on the retina.
Okay.
In normal eye, we get on the retina, but not on the in the defective
Okay.
eye.
Okay.
Now here the image is in front of retina, so I will not be able to see the image clearly. But nothing to worry, we can correct
Correct it, right.
Yeah, this eye, myopic eye, can see objects only up to distance O. You can see that point. The far point moves closer. Normally it is
Yes,
infinity,
right.
maybe it is 5 meter. Okay? So beyond 5 meter, you cannot see clearly. Okay? So at 5 meter, which here you can say O, the image will be on the retina. Now, causes, as we have already discussed, either the focal length decreases or the eyeball is elongated. Now, this is again for reference far point of the myopic eye. Now, let us see how we can correct it. This defect is corrected by a concave lens or diverging lens of suitable focal length. You can see in this diagram, we have a parallel beam coming on the concave lens. This concave lens is fitted in our spectacles.
Okay.
Okay, the lens is diverging the beam. Okay, parallel beam is entering the lens, and then the beam gets diverged, and it appears to come from point O,
Okay.
the far point. So at O, when the object is at O, in this defective eye, myopic eye, image can be produced on the retina.
Okay.
So what the lens has done, lens has brought the image of object at infinity to O, which you can see.
Okay.
So therefore the final image is on the retina.
Retina.
So this is how the lens is, the defect
It can
is
be corrected. Right.
The final image, as we said, is formed on the retina. So this is a clearer diagram which you
How it can be corrected.
see.
Okay.
Okay, just a repeat but a larger diagram for a better view.
Okay.
Correction of hypermetropia or long sight. I repeat, hypermetropic eye cannot see nearby objects clearly. Okay, you must this problem comes in old age. You must have seen people in old age hold their books or newspaper
distance.
away from the eye
Exactly,
because they
right.
cannot see nearby objects clearly. For nearby objects, the image is found behind the retina. Here N signifies the N dash here in the diagram signifies normal near point, which is 25 centimeter.
Yes.
So this eye cannot see objects clearly which lie at 25 centimeter. So such an eye is a long sighted eye. Okay.
Okay.
This eye can see objects at N or beyond N. You can see the diagram. So near point has moved away. Maybe
It's
if,
very
if
far.
the person is able to see say 50 centimeter and beyond, but cannot see object at 25 centimeter,
Right.
then this defect is hypermetropia.
Okay.
And we will correct it, we can correct it by using convex lens or converging lens of suitable focal length. That number or power is
Depends on
prescribed
number
by
and-
the,
yes.
the,
It
the
varies.
doctors.
Okay.
Near point moves away, not at 25 centimeter, but 50 centimeter, 75 centimeter, or depending on the defect in the eye. Now let's see how we can correct it.
Causes.
Before that, see the causes: increase in focal length. These are reverse of the myopia, or contraction in eyeball. When the eyeball becomes shorter, the image goes behind the retina and we cannot see the object clearly.
And we all use our lenses, or we can say specs, due to these.
To correct
Yes,
these
these to
defects.
correct, okay.
Yeah. Now see correction. This eye can see objects at N, but we want to see objects which are at N dash 25 centimeter. That is what will be normal. So we have to use some external aid so that we can see objects at 25 centimeter clearly. Okay. For this we make use of a convex or a converging lens.
Okay.
Now see how this is achieved. When the object is at N dash, that is 25 centimeter, we want to see it clearly, that is we want the image to be produced on the retina. So you can see the rays starting from 25 centimeter are entering the lens, convex lens, which is fitted in the spectacle. The rays are converged and appear to come from N, that is say 50 centimeter, which is the near point of the hypermetropic eye.
Okay.
So what has this lens done? This lens has moved the object at N dash 25 centimeter to effectively to N, which the eye can see. Therefore, final image is again on the retina, and the person is able to read clearly.
Okay.
Okay.
And here is the big
This
image.
is-
This is the clear image.
Yes,
how it
this
can
is
be
clear image.
corrected.
When it is formed on the retina, then then we get clarity.
Okay.
Okay, so this is a bigger diagram as we had in case of myopia. Now there is another problem, presbyopia, which arises with old age.
Okay, so before we move further, let me ask you some question. Like in most of the lenses, we see two parts of lenses. So why is it so?
Okay, we'll come to that. Lens with two parts, which
Yes, exactly.
as you must have seen a cut in the sort of, which appears to be a
Right,
cut
right.
in the lens, that is used to correct presbyopia. We are coming to this.
Okay, for this type of
yes.
defect. Okay.
Presbyopia is age-related problem where the eye loses its accommodation both for nearby objects as well as far off objects.
It is for both.
For both.
Okay.
Yes. So you need correction of nearby objects as well
And
as
the
correction for far off
far
objects.
objects, right.
Now let's see how we achieve it. It is very simple now, since we have already talked about myopia and hypermetropia. This is very easy to understand. This defect is due to weakening of ciliary muscles, or maybe sometimes the lens becomes less flexible, reduced flexibility of eyelash, that
Okay.
causes the problem. This defect is presbyopia, and it can again be corrected by lenses, and the lenses are the ones which you were talking about.
Okay, these are the lenses.
See, this is the lens.
Oh,
with a cut. Okay, when it's a here the upper portion of the lens corrects the myopia and the lower corrects the hypermetropia. So, when we look up, the upper part of the lens is used and helps us to see the distant objects, and the lower part helps us to see the nearby objects.
So, these are in the half parts.
Half
equally
parts, yes.
generated.
Half, matlab, you divide it into two parts. That design depends on eye to eye.
Okay.
You
And
can
sir-
see here the upper portion is concave lens, facilitates distant vision. The lower part is a convex lens, facilitates near vision.
Okay.
Okay. So, these are the three defects which can be corrected with the help of the lenses.
And
Okay.
sir, what's the next after this?
We will talk about prism.
Okay.
Okay. And nowadays it's possible to correct these defects with surgery also.
Okay.
LASIK
But
surgery.
they are sometimes harmful for our eye as well.
There is no evidence for this.
Okay, we can't say like
We
that.
can't say. Okay.
Okay.
Now let's move to the next topic, refraction of light through a prism. Earlier we have studied refraction of light through a rectangular glass slab. There the emergent ray, the ray after coming from the glass slab is parallel to the incident ray. Okay. But sideways displacement is there, which we call lateral shift.
Okay.
Now here in prism the things are different. IO is incident ray, OR is refracted ray, and ER is emergent ray. You can see the on passing through the prism, the incident ray which was originally travelling along IT comes out along RE. That is, it bends downwards towards the base BC of the prism. Okay. So, prism deviates light from IT direction to RE direction downwards through an angle which we call deviation. We will come to that in the diagram towards the base of the prism. Now, here why it happens? AB is the surface of the prism where light is entering from air to glass. IO is incident ray in air, OR is refracted ray in the glass. Okay. So, the light comes closer to the normal. So, angle R
also
is
see
less than
angles,
angle
yes.
I.
I.
Okay. On face AC reverse happens because here on AC OR is the incident ray, R is
Right,
the emergent
exactly.
ray, and it is travelling from glass to air. So, it bends away from the normal. Here we have angle E greater than I dash. Okay. At AC we have angle E greater than I dash. So, overall as a result of refraction through prism, light ray bends towards the base of the prism through an angle D. Angle D is marked in the diagram in blue color. This angle is called angle of deviation.
Deviation. Okay.
Okay. And you can see emergent ray and incident ray, they are intersecting where we form angle D. They are not parallel, unlike
They are intercepting each
they
other.
are intersecting each other,
Right.
unlike glass slab. Okay.
And sir, is there any real life application based on prism also?
Yes, it's a wonderful device. Seems to be very simple, but it's a wonderful device. Before that, let's talk about the factors which affect angle D, and then I'll come to answer your
Okay,
question.
for sure, sir.
Yeah. Angle of deviation depends on angle of incidence I, angle of prism A, nature of the material, and see the last part. Fourth thing is color of the light.
Color of the light. Okay.
So, these are the four factors which affect the angle of deviation. These are again listed here. Angle of deviation depends on angle I, the angle of incidence, angle A, angle of prism, nature of material of the prism, and color of
the
light used. Now, what we have is when the advantage
Yes, exactly.
application of this deviation or use of prism.
Prism.
The deviation, because the deviation depends on color of white light. So, if white light is incident on the prism, White light we know is a mixture of 7 colors.
Exactly.
Violet, indigo, blue,
Right.
green, yellow, orange, red. This we have studied in earlier classes. The violet bends the most, deviates the most, and red deviates the
Less.
least.
Okay.
So when the light comes out of the prism, we get a spectrum of different colors. Okay, the
Which we
violet.
also can able to see like rainbow. We call
Yes,
it
the
rainbow.
same colors in rainbow. Rainbow basically is formed because after rain, the particles, or should I say water droplets,
Yes,
left suspended
exactly.
in air, they act as prisms. Okay, and they produce the spectacular rainbow. Okay, because the angular deviation depends on the color of light.
Okay.
Okay. Now further applications of this splitting of white light, the phenomena is called dispersion, but interestingly it is used in study of atomic structure. It gives us an insight into the structure of the atom,
Okay.
because different atoms emit different colors. Okay, and that is what gives us a thorough insight into the atom. So structure of atom is studied with the help of deviation or dispersion with the help of the prism.
So there
About-
are number of applications we can
Yes,
see
there
of
are
prism.
number of applications, and understanding
Exactly.
insight into the atom is a very important factor.
Okay.
Okay, so prism seems to be a simple instrument, but
Yes.
it has wonderful applications.
And it has literally a very magic inside it.
Yeah.
Yes, okay. So sir, as we are left with a very limited time, so we have to wrap up this session for now. And is there any message you want to deliver to our students regarding this topic?
Yes, one very
Any
important
important,
message, since we are talking about human eye, it is very important that as and when you feel the need of external help, you must seek it. Never squeeze your eyes, never put undue stress
Very
on
true.
the eyes. The care of eyes is very important. And then you can see one more thing. Anybody without refraction defects can donate eyes. There are a large number of people who need
Very
it.
right, sir.
Who
Good.
need
good.
it. So it's very good if you somehow pledge the donation of your eyes.
Exactly. We have to
Okay?
think about that.
Yeah, organ donation is
Exactly.
extremely important.
So thank you so much, sir, once again for joining us today for this wonderful
Thanks
session.
a lot.
Thank you so much.
Thank you.
Okay, and along with this, sir, I would also like to thank our sign language interpreter Sonal. Thank you so much for joining us today. And at last, I would also like to thank all our viewers who joined us till last. And before I leave, please have a look on your screen for our upcoming programs. So within a few minutes, you can join us on channel number 6 to 12 for the program of online training, and the topic is visible on your screen. And after, followed by 5 p.m, you can join us on channel number 6 to 12 for the program of Sahyog, and again the topic is flashing on your screen. And at last, you can also join us for the program of NIPA on channel number 6, 9 and 12, and the topic is again flashing on your screens. So this is all about today's session. If you have any doubt or query, you can also connect with us or through comment box option. And now once again, namaskar.